What's up guys, it's Jake. We're back in the Holland Built shop with another video powered by SendCutSend. Today we're going to be taking this independent 9-inch rear end and we're going to be making a mounting adapter to put our brake rotors inboard on it. Let's get into it. Let's start by talking about this independent 9-inch rear diff. I got this one, so this aluminum housing here is from Dutchman Axles here in the States, is along with this 934 CV. So the flanges right here, so this thing's got stub axles on it, standard 9-inch pumpkin on it. What we want to do today is essentially create a flange, a mount that comes between our CV and our stub axle that's going to end up mounting our brake rotor inboard on this. This is something you can buy from Dutchman Axles, but this is a good opportunity to show you guys a little bit of a way to create blank materials for CNC machining that simplifies the build through SendCutSend. So let's bring it down to this piece of paper and we're gonna start taking some dimensions that we're gonna go to the CAD and get our templates made out of. So quick and easy way to do this is to put our parts right onto the piece of paper. We're going to be looking at doing something like this. And we don't really necessarily need to worry about our pattern yet, but I think we're going to end up doing a pattern that looks like this. We're going to go ahead and do all of our CV measurements in red. Let me go ahead and trace this out. I like to just use the parts to give me the layout a little bit so we don't have to worry about it. So as we do that, we can also come back in here and trace out our brake rotor on this. So we're just gonna roughly trace out our brake rotor. And what this is doing is just gonna tell me how many holes I need to put in this template. And then we're gonna go ahead and take our calipers and create some measurements as we do this. Okay, so now we can go ahead and pull this off. We can also pull our CV out of the way. We gotta be careful because this can all fall apart, so we wanna kind of pinch that. Okay, so now that we have kind of a general layout here, we're gonna go ahead and draw in our circles here. So this would be one bolt hole, second bolt hole on our rotor, and then we can do the same thing, hole and hole on our CV. So the first measurement we want to take is we want to know what this actual diameter is. So let's go ahead and take our calipers. So these are cleanly a 1/2-inch hole. So that looks great. That's easy math for us. So the next measurement we want to take is we want to know the actual hole spacing. So, we're going to end up having 1, 2, 3, 4, 5, 6 holes, and then we're going to end up measuring center to center on that cross right here. And so a quick way to do this is you can either measure the ID to ID on the 2 holes, or we can show it right here. We can measure from here to here, or we can measure from here to here. So it doesn't really matter which way you do it. If you measure on the inside of the 2, you're going to end up adding the diameter, right? That gets us back to the center of those holes. So let's do it as an example here. So if we end up getting this measurement of 3.7, we're going to call it 7.4, probably 3.745. That's it. Reading them upside down. Yeah, we're gonna say 3.745. We can draw a line in here. So we're measuring from inside to inside right here. This is 3.745. So we need to add the radius here and the radius here, which happens to be this diameter. So if we add that diameter there, we're gonna get, what, 4.245. So this is most likely a 4. This is most likely a 4 and a quarter split. So that's probably what we're gonna design it for. The next thing is we're gonna do is we're gonna just rinse and repeat. So we're gonna do this on the rotor next, do the same exact process by creating that hole pattern here. And then we also gotta remember that we want it to locate onto this stub axle here. So I want it to sit onto this shelf right here and locate so we're not like wish-washy out on the outside here. And we also need to have this small bore right here put into this, the center of this part, so that the center of our CV and the axle can twist and locate into those. So since we have a little bit of this kind of movement here, we have to have some clearance built into that. So let's go ahead. I'm gonna arbitrarily kind of draw a little half circle in here, and then I'm gonna call out the diameter. We're gonna take a quick measurement over here. So this is looking like 3.5. So we're gonna take that 3.5 in, or 3.5. And yeah, okay. And then one last measurement, we're gonna go ahead and measure this nice and accurately. If we wanted to get a press fit or something, we'd be using micrometers, but we're gonna end up oversizing this just slightly enough to have a nice slip fit. So we're gonna go ahead and just make this diameter 5 inches. So that's the outside diameter of our CV. So we have all the dimensions we have of the CV now. So we have a 5-inch outside diameter. We have a hole center to center. So our center to center is gonna be 4.25. We have that inside little pocket that we're gonna end up making go all the way through. That's gonna be 3.5 inches. We're gonna go ahead and do the same thing, and then we're gonna head over to the office, draw this up in CAD next, and start making our templates. All right, so I went ahead and took those measurements and we put them into CAD here. I actually ended up reversing the entire rotor and CV. This is gonna give me a little bit better of a depth perspective when I'm actually gonna be making these parts. The big thing that I wanna kind of show is that we can take and use SendCutSend to create a blank for us to CNC machine. So they can, instead of starting off with a big flat piece of material in which we have to do all the features and cut the part out, they can actually cut the part out for us, have most of the features put into it, and then we just do a little bit of finishing work. One, it simplifies all of the efforts that you have to put into it, whether it be like machine, like holding it down or tabbing it and having to cut the tabs off later. But it also requires us to not have all these like random scrap pieces of material and oversized piece of material that we have to find and source. We just kind of get the part that we need. So let's go ahead and look at this. I ended up creating a little pattern here, similar to what we did just in the shop a second ago. And we created a sketch. Using the holes, I ended up just projecting all of those features onto a nice flat surface. And then we can go ahead and extrude those, and we end up getting that mounting bracket that we're looking for. Now this current mounting bracket, we're gonna go ahead and take this DXF, and we're gonna take that to the shop. I'm gonna cut that out in that CO2 laser, just to double check hole placement, double check that, you know, the orientations, we don't have any weird things that are outside of our current views. I wanna check that that internal diameter here allows that CV to articulate the way it is intended to do in the end. And then once we double check that, we're gonna go ahead and extrude that and create these little shelves for it to sit on and auto-locate onto the CV and the rotor, so that we're not having to kind of line the holes up on a flat surface. It locates onto a little shoulder, and then we can put the bolts in. So let's go ahead, save that DXF now. I'll go double check it, and we'll move forward from there. So off camera really quick, I went out there and double checked it. There was a couple things that I have to fix. First thing is that the holes on the CV, they were too small. We have the shoulder bolts that are gonna end up going into those. I forgot to make them the same size as the shoulder. So we went ahead and fixed that, and I made them slightly larger to fit that shoulder. The inside The inside here, diameter was great for the CV axle. It allowed it to articulate like we wanted it to, as well as the patterns all matched up. So I went ahead and did that. The next thing I did is created I created that little shelf for our CV and our rotor to sit on. So if we bring in our rotor here, we can see that our rotor will end up locating onto this little shoulder right here. And our CV will do the same. So we can kind of see in here in that little blue line that our CV is going to be located. One other way we can look at this is we can come in here and we can do a split analysis. And when we look at it from that side view, turn off analysis, we can see here that we're going to locate right here on that corner, and we're also locating in on this corner, as well as our holes are all nice and lined up. So the next thing is now that we kind of have all the design done, we're going to go ahead and switch over to the cam side of things. So in this one, I'm using Fusion 360 for my personal stuff. This one has a really cool built-in cam feature, so I can go straight from that modeled part and go to the cam. So let's go ahead and do that now. We're going to turn off analysis, turn off those other parts, and we're going to switch over to manufacturing. So the big thing is on this is that we can look at our thickness of our material. So on this one right here, I went to SendCutSend's website and I chose a 375 thousandths thick aluminum. That's the thickest aluminum that they have. It's in the 6061 series. We're gonna go ahead and use that. We're gonna maximize the thickness that I think I can get away with here. So we have a 1/4 inch thick flange, and we're gonna end up having that 135 or 125 thousandths shelf there, right? To make up that 3/8 thick piece of material. So like I said earlier, the cool thing about SendCutSend is that we can essentially get this blank cut out that we don't have to cut out of a plate. So another way that I would end up designing this would be having a plate, and then I'd have to contour my end mill all the way around this thing. That's a super great way to do it. There's nothing wrong with that. But if you say didn't have access to a CNC machine, you could just cut this out of 1/4 inch material and you'd be done, right? You'd have that mounting flange. Or you can cut it out of this 3/8 material, and then we can groove in these little lips and stuff and make this part a little bit more versatile, a little bit easier to locate, when we're putting it together, that aren't necessarily needed features, but maybe it makes it a little bit fancier. And we don't have to do as much machining on the back end. So what I ended up doing is you can go ahead and undersize your holes. So I'm gonna go ahead and actually interpolate and re-pocket all of the holes that SendCutSend is gonna be doing. So all of my holes are gonna be 10/1000ths of an inch undersized. That's gonna be just enough that I can come in on a full depth and just do one single cleanup pass on every single hole, as well as use those holes as a locating fixture in the machine. So let me show you kind of how I did that. I went ahead and created a plate on the bottom. So we always have kind of random scrap pieces of material laying around, and in that material, I'm going to drill and tap these 1/4 inch 20 holes in that plate. These are going to be used to mount the plate down to it. I typically have a plate in the shop that I use that I just kind of do this kind of stuff to. I just turn it into Swiss cheese as I make different parts on it. So I'm gonna go ahead and use that plate. We're gonna mount this down, and then we can do is create all of our different fixturing on it. So we're gonna do this in 2 different operations. We're gonna first mount through one hole and then do all of our outside holes. And then we're gonna switch our bolts to our outside holes and do all of our internal holes. And then we can go ahead and actually look at that final simulation and see that we have a plate in here. We can see how that's just gonna actually end up contouring and removing this material out of here and ending up with the final part that we actually want. So we're not gonna actually see any material being removed here necessarily because we don't have any material to be removed other than that little 5,000th variance here. So now that we kind of have that settled out, we're gonna go ahead and take this to the CNC once we get these parts. So I'm gonna go ahead and order these parts from SendCutSend, get these parts back. We're gonna go straight to the CNC and machine these parts, and then we'll go to the shop, check it out. Like we talked about in the office, we got all the cam stuff kind of taken care of in the background while we made sure, while we got ready for this part to come back to us. We got the part to us now. I've gone ahead and made that fixture by putting all those tapped holes in that we talked about earlier. So let's go ahead and look at what I got here. We have tapped holes. I just have a random plate here that already had a bunch of holes in it that was scrapped in the shop. There's tapped holes, 1/4-20 in all of these holes also. So I went ahead and put all of the bolts in, tightened them all down so everything's all nice and centered. We're gonna go ahead and run the first operation of this program, which is gonna thin out this outside, turn this contour on the outside, and then true up these holes to the actual size that we want. We'll go ahead and switch to the second operation by moving these screws out to the outside. We'll turn down this inside area and clean up those holes, as well as this inside contour here to match that CV. So let's get into it. All right, so the first operation's done. We turn down that outside. We have a little recess. What I want to do really quick before we switch over to the second operation is I want to check the fit, that locating fit that's on the outside of this on the rotor. So as we kind of come down, we have this beautiful fit. Look at that. And the holes all line up. So we're good to go. We're gonna go ahead and this is actually gonna be flipped over this way, but since I can't check it, we're just gonna flip it this way. So when we actually mount it on the car, it's gonna be the other way. So we have a nice flat surface that these are now mounting to. We're gonna go ahead and swap out these screws. We're gonna move them to these outside locations here so that we can turn down this inside ring and true up those holes also. So let's get after that. All right, second op is done. Everything looks really good. We're gonna go ahead and take this off, go over to the car, put it on there, get everything kind of bolted up, check the fitment. At this point, everything is done. If we take this thing out, putting it back in is gonna kind of mess up all of our tolerances and stuff. We did all this in one setup so that we didn't mess up and move anything. So once I take this out, it's most likely not gonna come back in the machine. But we did check already that rotor placement, everything looked really good there. It was the same tool that did this inside groove, and we have a little bit more room on the inside one, so I'm not too worried about the fit there. So let's go back over to the car. Back in the shop after the CNC, I went ahead and cleaned these up a little bit and deburred them. Let's look at the location on the back here. So if we come in, this is it's a little bit of a loose fit, but we don't have really any wiggle. We can hear just a little bit of a knock. That's gonna help us kind of hold this on. And all we have to do is get the orientation right to get those bolts in. I went ahead and mounted one of these rotors up already. So we're gonna do the same exact fit. Put this on. Hold this up. Once we find that bolt hole, there it is. Help it slide right in. We can start screwing that on. The same rinse and repeat with the rest of these bolts. Everything's sliding back in. Remember that the holes in this plate right here and the adapter plate are fitted to these shoulders on these bolts. So we have a nice tight fit here. We're not gonna be on those threads. It'll be a little bit stronger that way. The rest of these just started for you. Because now we have a nice mounted brake rotor to this housing. The next thing I'm gonna be doing is there's some large holes up here. These are mounting holes from Dutchman axles. I'm gonna go ahead and actually use these to mount my calipers on. Since we're kind of in a tight space, I'm gonna have the calipers just slightly rock back for bleeding purposes, and then I'm gonna pinion mount the front along with the mounting on the bottom. So we're gonna have those inboard rotors. A big thing on the inboard rotors, like we talked about, is that these end up saving us all that unsprung weight out there at the wheel. It helps us be a little bit more centered with the center of gravity in the car. and it helps us to control that tire movement. It's less work for the shock and the springs to do. So if you like this video, we're going to be doing a lot more on the car, so stay tuned for more.